Well, the project in the shop today is a Easy Go Marathon. They made the Marathon in gas or electric. This is an electric, 36 volt. This one is G0790. I believe that indicates that 07 would be July, and the last two digits 90 means it's a 1990. They made the Marathon until 1994, I believe, and then they went to the Medalist for a year or two, and then they did the TXT, and I'm not sure, they might still be making the TXT, and I don't even know what the newest model is. You see a tremendous amount of TXTs around right now, but not so much the Marathons anymore. So what's going on with this cart? I don't think I was very clear on exactly how this thing was acting up. Mostly it was underpowered when you put your foot on the accelerator pedal. It didn't have enough power to get itself going. Sometimes we would push it, one person would sit on the seat and push the accelerator and someone else would jump off and push it, and once the thing got rolling, it tended to have enough power to carry itself. It would not climb hills though. Most of the time it didn't have enough power to pull a hill. It just wouldn't make it. There were other times when you would get on it and you would, put it in gear that it would just jump. Rather than kind of easing into the throttle, it would just all of a sudden just, jump right up to, like it jumped into high speed right away. It didn't do that very often, but it did that sometimes. So there are essentially five major components with the electrical system on these things. You've got essentially you've got the switch, which controls forward and reverse. Some of the power runs through it somehow. I'm not entirely sure how the switch works. So you got the switch, you got the solenoid, which is basically, it's a 4-post solenoid. You got two low voltage wires and two high voltage wires. So the two low voltage wires trip and engage the two high voltage side. It's your basic solenoid. You have a, what the hell is that thing called? It's got a weird name. Shoot. The name of that apparatus escapes me now. But it is what it is attached mechanically to the foot pedal. So this thing, we were probing around on it yesterday. Believe it's good. This is your speed controller. This is I don't know what's going on. It's an electronic box. It's about 4 inches wide. 4x2 by about 6 or 8 inches long. That's the speed controller, and then the other electrical component should be right there. That's the motor. And between those 1, 2, 3, 4, 5 things, that's pretty much the electrical system. You got their charger and the switch and stuff like that, the key switch. Man, what is the name of that thing? I can't even remember the name of that. Anyhow, again, this is not my forte. So, in diagnosing this thing, we started last night. My brother-in-law came over. He's a lot better with this electrical stuff than I am. And him and my nephews and I, we were probing around on it. What is the name of that thing? Anyhow, that thing, when you press the pedal, should have, or actually when the pedal's not pressed, you shouldn't get a reading. If you're checking your resistance on it, it should range anywhere from 0 to 5 ohms. So when the pedal's all the way down to the floor, it should be reading 5, and it should, as you raise the pedal up off the floor, your throttle pedal, as you raise the throttle pedal, that reading should go lower. So it's 5 at the floor, 4, 3, 2, 1, 0 as you let off the pedal. That one runs to 6. 6 is a little over 5, but I don't think it's terrible. So we're going to say that is probably good. The other component that we tested would be the solenoid, and that solenoid, odds are, if it were going to go bad, it would just all go bad. It wouldn't allow low voltage through. So we were testing the solenoid, apply voltage to it. It closed the connection between the two high voltage sides. it seems to be working. The solenoid appears to be working. It's clicking. It's allowing voltage through, and I don't think that that's our issue. The switch, yeah, I mean, it goes into forward and reverse, and have never had any trouble out of it not going into forward or reverse or neutral. So I'm gonna kind of assume, and I know we're kind of gonna assume that the switch is okay because it does select between forward, neutral, and reverse. So we've kind of eliminated hopefully we've kind of eliminated these three apparatus. The things that we're left with are the motor and this speed controller. Well, the motor, I would think, is probably okay. It could have bad connections, yeah, which is causing it to, not function up to speed all the time, not getting full torque all the time. So what we started to do was to clean up the connections. I thought, the easiest fix on anything is to clean up all your terminal connections. Take off all the nuts, clean them up, clean everything up with sandpaper, put everything back together. So we started doing that. I did that on all the switch connections. Nephew was doing that on all the battery connections. He even did the, that thing there. I don't remember what the hell it's called. We did the solenoid. We were doing all these little connections. I got to the battery, or to the motor, and I thought, well, I'll go ahead and clean up those because those look like they've been painted over. Well, the first one was really stuck on there because it had been painted over. The second one, I think this was the second one I did. This was the first one I did. The second one I did, that nut really didn't want to come off of there. And in fact, the stud then bent. Well, shit. So I went ahead and forced it the rest of the way off, cleaned up the connections, putting it back on, putting the nut back on, and that bent stud snapped. So that's where I'm at right now. The last two came apart reasonably well. So right now I've got the motor. The motor then dismounts from the gear drive, the rear end. I think it only used 3 7/16 bolts. That's it. Or 7/16 head, 1/4-inch drive. That's all it holds that motor with all that torque to that rear end is 3 little 1/4-inch bolts. I don't know if we're missing one, but we only took 3 out of it. I'm having a hard time wrapping my head around that much torque from that thing being contained by those 3 little bolts. But that was factory, so that's where we're at right now. I'm going to take this motor apart a little more. I need to replace this stud, and since I'm going to have to replace that stud, I might as well go ahead and get in there and clean it up a little bit. I'm going to take out these 2 bolts here, and that should allow me to pull this bottom cap off. And with this bottom cap should come this, I don't even know what you call it. I hear these terms and I don't know them. Again, I'm not an electric guy. It might be an armature, rotor, I don't know what the hell you call it. The guts of the inside of the motor. All this turning stuff, that turning stuff is held in by these 3 bolts here, I think, or screws. That's probably a bearing that is probably attached to this plate. So when I take these 2 bolts off, this plate, all the turning stuff and everything should pull out the bottom, and I should be left with a shell of magnets around the outside. These should be the magnets. So I'm going to take that apart, clean it up, and then I'll show you guys what I find in there. So I took out the 2 bolts on the bottom here. I left these 3 screws in still. I took out these 2 bolts. They're 7/16 head, and then I started to tap with a hammer very gently, tap the edges, tap that cap down and separate the 2 housings. You have to loosen up these jam nuts on the bottom of the stud a little bit, and these 2 studs stay with the bottom. These 2 studs are kind of wiggly loose. They're attached to wires that go with the top. So make sure they don't all stay stuck in the bottom, because all 4 studs wanted to stay stuck in there because this has been painted. So anyhow, make sure you're not damaging anything there. Well, I got them apart, and my fears have been confirmed. When I was taking this thing apart, not only did I snap the stud, but the thing, I could tell it was moving in there, and I mangled up that wire. These studs are welded on to the ends of these wires. You can see a little bit of weld there. This is it's like a copper plated stud. This is essentially the same thing. You can see that it's about big around as a dime. That square part, that's the end of the wire, which is welded to that round part, which is the stud that I broke. So not only did I break the stud, but I also mangled that wire by spinning that stud in the housing. That stud was turning with my wrench, so I twisted that wire up real bad. So I'm gonna have to get in here. I'll be replacing that wire or making some other repair to that wire in addition to buying new stud. Well, now you can see what I've done here. So I twisted off these two. Should have been, you know, both those wires are wired together and then crimped in that flat square piece, and then they you know, of course, are welded into that stud. So the ends of these wires should go together. Each wire is attached to a brush. These are the brushes. So every other brush is attached. So like these two are attached and these two are attached. So this is the wire that goes over to this brush. This is the wire that goes to this brush. Same thing over here. That one goes to that. That one goes to that. I'm hoping that possibly I can find a set of brushes, and because the wires are attached to the brushes, I don't know. Let's see if the wires are kind of permanently attached to the brushes. Yeah, I'm gonna have to take that whole plate out of there. I'm wondering if the wires are permanently affixed to the brushes, if I can just order a set of brushes and these will come attached together, and that'll save me some hassle. Then I can just replace the brushes in here, which is not a bad idea, you know, just for regular maintenance anyhow. But get on the internet, do some searching. The insulating material down in these holes, some of that broke as well, so I'm gonna have to round up some of these plastic washers. These other studs, I was able to get this one disassembled. This one I haven't really tried yet. This one here I can't get the nut off. I put two nuts together as jam nuts out here, and it's pulling the threads off of these. Again, these are like I don't know if they're a solid copper stud or if they're just copper clad, but the threads are really soft, and I can tell my jam nuts then were kind of pulling the threads apart. So I'm thinking I'm going to be redoing all four of these studs. So I'll have to order 4 studs, break that off of there, re-weld, you know, all 4 new studs. If these come together with a brush kit, that'll save me having to weld 2 of them. I'll just be welding new studs on there. So I'm gonna have to round up some parts and I'll get back with you guys. All right, well, here's where I'm at. I went in, looked online, and this stuff is ridiculously expensive. It's really hard to find, and I'm gonna have to wait forever for it. Some of this stuff is like temporarily out of stock, and it looks like I'm just gonna have to make do. I should have prefaced this whole video, or at least this portion of the video, with saying that I called around. I live in southeastern Indiana. I called every electric motor repair shop in the tri-state area, all around Cincinnati. I didn't quite get down to Louisville, but I probably called a dozen electric motor repair shops, and I couldn't find anybody to rebuild this for me. So I should have said that right off the bat. That's why I'm tearing into this thing, because I don't feel comfortable doing this. So all that being said, I can't get nobody else to do it. I guess I could pay to have, there's a place called plumquick.com or something like that. They make like, you know, high performance motors. It would cost, I think, $285, plus I have to ship them this core, and they would rebuild it and send it back to me. So that's kind of my only option right now besides doing it myself. So anyhow, what I come up with was this stuff. Again, this cart is 1990. That means this stuff is, as of right now, is 31 years old. So all this plastic stuff is real brittle, and it's breaking and cracking. You know, the threads are all buggered up on these studs. These studs, I did find them, but they're like $6 plus shipping. And I only could find them at one place. Everybody else said they were out of stock. So anyhow, what I did, okay, so what I've come up with, this is an insulator supposed to sit down in there. It's like a little square thing. It's supposed to sit down in there. This, of course, this one's broke in half. So I need to replace that. I got some 3-foot long zip ties. The head of those zip ties is just about exactly the same size as that. So I cut the head off of it, drilled it out to 5/16, and that thing fits in there really well. Fits in there really nice. Had to grind it down a little bit because it was a little too thick even. Other than that, that fits perfect. So then I get to these washers. These are some sort of plastic. They're a hard plastic washer. They're brittle. You can see that one snapped in half. Well, I could do some like rubber plumbing washer or something like that. Or I got a piece of scrap UHMW. This is, I don't know, I've had this forever. This stuff doesn't tolerate daylight very well, but this thing ain't gonna get much daylight, so UV breaks that down really, really bad. If you guys are ever doing any project with UHMW, I know a guy that recovered a hay rake with that stuff. It didn't last but just a couple of years because it sat out in the sun. It got so brittle it busted right apart. Anyhow, UHMW is a plastic insulator, so I'm cutting washers out of UHMW. I'm using my hollow punch set to knock the center out of them. That's the worst part of making them. So with a hollow punch, this is not that bad, and I'm just cutting washers out. So the studs, so I'm going to be able to reuse this stud no problem. This one here I didn't even take out of that housing. I did run a wire wheel around it. You can see it's kind of buggered up there on the end, but we're going to go with it. This one was the one that I broke. That's that one. So what am I going to do for a stud? Well, they are steel. I put a magnet to it. It's steel, but it's copper coated. So it's copper clad steel. Well, I'm not going to have anything exactly like that, but it's 5/16 thread, or 5/16 diameter, 18 thread. 5/16 18 bolts are pretty common. So what I'm going to do is, it's not going to be copper clad, so it's not going to be you know, as conductive, but it's going to be pretty conductive anyhow. And the way that these things are all worn down, and the way that the bolts bite into the threads, I would say there's probably a lot of steel to steel contact anyhow. The nuts are steel, so I don't think I'm going to be losing that much conductivity by using just a steel grade 8 bolt. I took a piece of copper, 1/4 inch copper tubing, plumbing stuff. I cut it about, I don't know, what is it, 1/2 inch, 3/4 inch long, smashed the one end down flat, and then I brazed it onto the end of that bolt. I opened that up just as wide as I could, and I took these 2 brushes, skinned back the wire a little bit, wrapped them together, and tucked them in there, and they are going to fit in there. So I'm going to put dielectric grease up in there just to help, I don't know why, I just like dielectric grease. I'm going to put a little bit of dielectric grease up in there. I don't want to get carried away because I don't want it getting all over these, brushes and whatever that thing is. So I'm going to twist them together, put some dielectric grease on them, shove them up in there, and I'm going to crimp them down with this. Just my regular crimp tool. I'm going to use the uninsulated or non-insulated portion of the tool with that nipple on it. And we're going to go with it. Well, there it is. Got my brushes both twisted together, shoved up in there, crimped, and they are in there really tight. So I'm going to wire brush the threads and reassemble this thing. Well, we got the motor all put back together. I say we, my sister, her husband, and their 2 boys were just here. And they all helped me get the motor put back together. My brother-in-law's he's pretty handy with all this electrical stuff. Well, he's handy with a lot of stuff, but he brought his tester and he probed everything after we got it all put back together, and he said it looks pretty good to him. The coil, or the oh heck, this up here, he said probed out really good, but this down here with the brushes on it, he said was getting a little more resistance than he would like to see, but we'll see what it does, you know, when we get it put in the cart and everything. He also was looking at the ignition switch over here. He noticed that this ignition switch is really wobbly. I think you can see that even though it is dark. And that's not just the wire wobbling, that's the terminal on the switch. And he was probing that while he was wiggling it, and he said it did affect the, you know, it was affecting the readings. So that could be part of our problem as well. So we're going to bypass that. We'll bypass that switch tomorrow. We'll put the motor in, and then he's, like I say, he's got some ideas on how to diagnose that controller. He looked up some stuff today. So it is 10:04 p.m. and I'm going to take the boys out fishing tomorrow. So I'm going to get inside, get cleaned up, get to bed, and we got a bright and early day tomorrow of fishing in the morning, and then fingers crossed, maybe we'll get this thing figured out tomorrow afternoon. Just got back from the lake. We had a great time. Well, here we are a few days later, and you'll notice that we've got a toggle switch mounted in place of the ignition, the key ignition switch. We did away with that because the terminals were so bad on the back side of that switch. And since we never took the key out before, it was always kind of a liability, actually. We're just waiting for one day that, you know, one of the kids would jump off and take the key with them. So we put the key, or we took off the keyed switch, we put this toggle switch on. We actually didn't even need to change the terminal ends on the wire there. So that was a real simple fix. So we took that, you know, variable out of the equation. So now we're sure that that's making good connection. When we put the motor back in, and that motor, you saw it finished on the bench. Of course, it's back in there now. To mount the thing, there's only 3 bolts that hold it in, and it's pretty self-explanatory. We connected the, you know, the motor wires back up where they went, and amazingly, the thing is working fine now. We took it on a test drive after we got the motor done and the switch put in. You know, we didn't have the seat on here. I was sitting kind of precariously on the corner there. My brother-in-law had his electrical tester, and he was probing the top of that speed controller. Of course, this plastic cover was off again. But he was probing that as I was driving, and whatever numbers he was looking for, he said they looked good to him. We went ahead and then we started to kind of stress test the thing. We put, of course, 2 adults on the, 2 adults on the front here. We put 2 adults on the back, and we started driving on hills and stuff, which that's where this thing struggled the most. It would not pull hills, and it did great. It's actually driving perfectly now. When you press the throttle, when you start into it, it comes in very gradually, and then the more you press the throttle, the faster it goes. It's acting just like it should. It's pulling hills great. So I don't know if me twisting that wire off in that motor was the problem, or cleaning the studs up on the motor was the problem. Maybe those were, extra corroded. They were really grungy. They'd been painted over before. But the more I think about it, when I was in that motor, that one stud that we had to replace it because the wires were twisted off inside the motor. Now, I remember when I was cleaning those studs up, I know I turned that stud, I think 1.5 or 2 turns. Now, those wires were twisted around. They were still twisted 3 or 4 times inside that motor. I think somebody else had twisted that stud so much that it had, more or less broken those wires, and there was still a little bit of connection being made, but it was just enough to where the cart still worked, but it didn't work like it should. I think me twisting those wires was, sort of the straw that broke the camel's back, or just kind of a coincidence that I twisted the same stud that someone else had already twisted pretty significantly. So I think that was our problem. It could have been, you know, that switch, but I really don't think it was. Again, we tested that component I couldn't think of before that lives under here. It's called a potentiometer. That name escaped me, but so the potentiometer was testing between 0 and I think 6,000 ohms. And don't quote me on that. It's maybe those numbers are correct. It's supposed to be 0 to 5. I think it's 5,000. But again, this one tested out to 6 or 6,000. So at 7, the way I understand it, these systems are set up at 7. If it goes to 7, then it kicks out. The controller will kick out, and the cart will die. So anyhow, that's the potentiometer tested out fine. Speed controller tested out fine. We cleaned up a bunch of other studs and stuff. It didn't seem like it really made any difference, but everything is working fine now. So hopefully this video will help you guys if you're working on one of these things. Again, this is an easy-go marathon. This is an older model, but I think a lot of the electric golf carts share the same sort of components. It's very possible that you'll run into the same sort of issues out of other brands or other models. If you're beating your head against the wall, you just don't know what to try, try some of these things. It might help you. I hope I helped you with this, guys. If you're really beating your head against the wall, and grasping at straws, this is maybe something. If I did help you, click that thumbs up button. If you want to see more videos like this, click the subscribe button. And until the next video, keep on tinkering.